Well, welcome everybody to the August Tech Night meeting, subject to grounding and bonding. Uh, I'm giving the presentation from home because it seems like we have enough audio problems when we present from the church that the Zoom folks are either not hearing anything or hearing feedback. So Bruce and I are used to doing it this way with the classes, and I thought maybe we would do it this way for Tech Night as well. Let's see. Yeah, if you've got a question, make sure you unmute yourself and then ask the question. And Bruce and Patty, if you have access to the chat room, if you could monitor that like you usually do, I'd appreciate it. Okay, all right, so let me get the presentation started here. Okay, so everybody should be seeing a title slide tonight, Grounding and Bonding for the Radio Amateur. This will be a quickie presentation, I think, and it won't be just me. I've got some coming in to talk for us. But this is an important subject for us, it turns out. Let me get that over here, page down. Okay, so let me give the disclaimer right away. I am not an expert in electromagnetic effects. I am not a double E. There are probably folks in the audience that know a heck of a lot more about grounding and bonding than I do. But I was the one that offered to give the presentation tonight. So I know I can learn the basics and hope to pass some of that on to you tonight as we go along. Most of us have a real hard time getting excited about grounding. It's not exactly a fun subject. It's kind of like life insurance or home insurance. That's not a fun subject either, but it's pretty important to us. The subject of grounding and bonding, and the presentation will get into what the difference is if you're not aware of it, can get complicated sometime, but you know, some electronics can get complicated too. And so just like as you take the path from technician license to general to extra, you learn what you need as you go along. So sort of eat the elephant a bite at a time. Like a lot of folks, I'd rather spend my money on some shiny new transceiver than on a bunch of grounding stuff that gets buried, nobody even sees. But if you ignore grounding, you just might get the opportunity to buy that replacement radio after all. So hopefully this will do you some good. Why should we even worry about grounding and bonding? Well, first of all, Florida is the lightning capital of the USA. We lead the nation in fatalities and injuries that are caused by lightning, and about a third of the days of the year have lightning storms involved in the state. Lightning is 3 times hotter than the surface of the sun, so there's a lot of energy there. As amateurs, we typically put up long wires high in the air, you know, and so that's almost more of an attraction to lightning than a regular house. So what can we do to protect our equipment, to protect our homes? We're going to talk a little bit about that tonight. A fellow named Ward is going to talk about it too. And by the way, grounding and bonding goes beyond just lightning protection. There are actually 3 main concerns. The first one, I hope you can see your cursor move in there, is up here on the top. Actually, your power system, your 115 volts transitioning into your 13.4 volts DC, whatever. There's a safety concern there to make sure people don't get hurt, don't get shocked, don't get electrocuted. The second element is lightning protection. That's the one that we think about the most probably in terms of grounding and bonding. But the third one, which is actually more of a bonding issue, is RF management. There's RF flying around the environment everywhere. And how do you control it? How do you make sure it isn't getting into the wrong places? There's some steps you can take to manage radio frequency waves. Now, there's a good reference book out. It's called Grounding and Bonding for the Radio Amateur, and that's where I took this presentation from. I recommend you get a hold of it, or at least take a look at it. There is a copy available in the NOARC library. Additionally, a lot of the members have it on their own. It's not a long read, but there's a lot of information in there to cover, and a lot more than I can cover tonight. So we will take some information out of that book. Now, what we're going to go through now is the fellow who wrote the book, literally, Ward Silver, November 0 Alpha X-ray, And he gave a talk to the Virtual Ham Expo a little over a year ago. It's a really good talk. It's only about 30 minutes. He goes into hits the basics of all tops of these, and I've stolen it, so he can give a better talk than I have, and you're probably interested in hearing somebody else's voice anyway. So Ward's talk's going to come on. He will come on. You won't hear him for a minute, and then you'll see him bring his presentation up, and finally you'll hear him speak. So don't worry about your sound right now. As I said, this was a presentation that was given August 8th and 9th a year ago at the Virtual Ham Expo.
Hi, I'm Ward Silver. I'm going to give a talk on grounding and bonding for home HF stations. And I'd like to thank Contest University and ICOM America for supporting the original version of this presentation. I've been licensed since 1972, first as WN0 GQP and then N0AX in 1975. Mostly I do HF operating, but I'm enjoying more VHF today. My interests are technical. I do a lot of radio sport and public service. My background is an electrical engineer. I have experience in instrumentation and medical device development. Began a second career as a teacher and writer beginning in 2001. I was the author of the QST column Hands on Radio that ran for 15 years, and there was tremendous interest in the columns that I wrote on RF grounding, and so I suggested a book to the ARRL on grounding and bonding to collect the information together, and the first edition was released in 2017. It's been pretty popular, and it results in me giving this talk quite a lot. The goal of the talk is for you to understand what ground and bond mean. We use the words a lot. It's important to know exactly what they mean under the different requirements for AC safety, lightning protection, and RF in your station. I'll discuss issues and techniques for these home stations. Primarily it's an HF talk, and we'll talk primarily about a common system that satisfies all of these requirements. And I'll provide comprehensive resources that are available after the Q&A slide that you can look at when you download the presentation afterwards. For ham radio references, though, your primary references are the ARRL Handbook and the ARRL Antenna Book. I'm the editor of both, and I've added a lot of information on grounding and bonding to the last few editions. You can also get the National Electrical Code at your library. You want the NEC Handbook, which is the big thick version. Any recent edition will be fine for our purposes, and you can copy the sections, they're called articles, out of the book that you need. You should also look at the 3 articles in QST from 2002, Lightning Protection for the Amateur Station by Ron Block, NR2B. It's associated with polyphaser. They're available on the ARRL website, and they're available freely to the public, not just to members. There are a couple of really good tutorials on Jim Brown, K9YC's site, Power Grounding, Bonding, and Audio for Amateur Radio, and RFI ferrites and Common Mode Chokes for Ham. Jim was a reviewer of the book, as was Ron. A lot of good material on Jim's book. And W8JI's web pages on ground systems are quite good. Tom lives on a hilltop with a 300-foot tower in Georgia, and he knows a lot about lightning. Here's the grounding and bonding book. It covers these 3 areas: AC wiring, lightning protection, RF management, safe and useful practices that were reviewed by a number of experts, including the ARRL lab. I'm highly indebted to these folks for sharing their expertise, and they kept me out of a lot of trouble, and hopefully you too. There are numerous examples for you to use in the book, but I want to stress this is not a cookbook. There's no one-size-fits-all. So this is primarily a toolbox talk. It's a toolbox book. You learn about how the tools work, and then you go back to your station and use them under your circumstances. Let's start by talking about what is ground anyway. The word has different meanings the way we use it here in North America. It can be a noun, as in an earth connection, and that's primarily how we talk about it for AC safety and lightning, or it can be a local reference potential in circuits or RF. Airplanes, for example, use the term ground, but I don't see any of them dragging a chain, so they must just be referring to the local reference voltage up there in the airframe. It can be a verb, meaning I'm going to ground something. I mean, I'm going to connect it to my reference potential. It can be an adjective describing a type of conductor or system. And it can mean all these things in the same time in the same sentence. So you wind up with people talking to each other about grounding using sentences like, I'm grounding the chassis to ground with a ground wire. And ground means 3 different things in each use. So you have to be careful about how we use it. There's one myth about ground. The Earth is not a magic sink into which you pour the RF and it just somehow magically goes away, or lightning, once it hits the Earth, we don't have to worry about it. That's not exactly true. The Earth has resistance, it has inductance, it has volume, it has surface area, and so it can do a lot of different things electrically. We can't assume that it's just a magic 0 volts. So you need to make sure that when you talk about ground, you're just talking about a local reference system, not so much a magic 0 volt thing. Let's talk about bonding. Bonding is just a connection intended to keep 2 points at the same voltage so that everything goes up and down together. That's all it does. That's all it means. And that prevents shock hazards, which can be caused by voltage differences. If you have one appliance up here and something else is grounded down here and you happen to touch both points, you'll get a shock. So by bonding everything together, you keep your equipment exposed metal at the same voltages, and that reduces the hazard from shocks. Destructive voltage differences can be caused by lightning surges. When a big pulse of current flows through a system, it can cause big voltage differences. So you want to minimize those by bonding stuff together so that everything goes up and down together. That's a recurrent theme of this talk. And by keeping the voltage differences between devices to an absolute minimum, what causes current flow? Voltage differences. So since RF pickup causes voltage and the current causes RFI, if I can minimize my voltage differences, I can also minimize the current and any problems it causes. Most RFI is caused by current, not voltage. So let's minimize the voltage differences by bonding, keeping everything together. We can also work in our favor for RF. It sounds hard and expensive, but it's really not. And the good news is that by working on bonding, works in your favor for AC safety, lightning protection, and RF management. But for it to work, it has to be low impedance. That means low ohms, either reactance or resistance, and it has to be electrically short at the frequencies of interest. Down at AC, where the wavelength's about 5 million meters, that's not so hard. But up at 10 meters, for example, well, the wavelength's a lot shorter. Anything over about a 20th of a wavelength is going to start acting like a transmission line, not so much a grounding wire. So you want to make sure everything stays as short as possible at the frequencies you're trying to manage for bonding to actually work and keep everything at the same voltage. It has to be heavy enough to carry the expected current. This is true at AC safety, where you're trying to carry fault currents that are heavy enough to trip a breaker. It's also very true at lightning, in lightning protection, where you may be trying to handle hundreds or thousands of amps for a short period. That's why you see the requirements for number 6, number 8, number 4, number 2, heavy wire. It also has to be sturdy enough to survive the environment, particularly outdoors where it's often buried, and so it's subjected to frost heaving in the northern areas. We drive over it, we dig it up, hit it with shovels because we forgot where it was, and so it has to be sturdy so that it maintains its electrical connection under all sorts of mechanical abuse. Inside your station, though, the commercial and military standard is solid strap. 20 gauge strap. It can be something as simple as strips of flashing. It can also be heavy wire, all that Romex we saved because we can't bear to throw any pieces away. All that number 14 and number 12 wire is perfect for bonding inside your station. If your equipment moves around, you can use the tinned flat weave braid, the silver stuff. but don't use the exposed braid from the old coax, because the minute you take it out of the jacket, all those little wires that were carefully braided together, they loosen up, they're exposed to oxygen and water, they begin to corrode, and pretty soon you don't have a very good connection. So if your equipment has to move or it vibrates, then use the flat weave braid, but the best stuff is the solid strap or heavy wire. If you want to use that old coax and we don't want to throw anything away, leave the braid in the coax, just waterproof it at each end and put a terminal on it, use it as a big wire, but don't expose it. Never use braid where it can get wet or exposed to chemicals, because it will corrode, and every corroded contact is a nice little rectifier, harmonic generator, noisemaker. You don't want it. AC safety grounding. It basically has several names: equipment ground, third wire ground, green wire ground. It needs to be a low resistance connection, because it only has two purposes. It provides a path back to the AC common point for fault currents like short circuits or leakage from compromised insulation or excess capacitance. The other thing it does is it helps stabilize the power system voltage during faults or transients, such as a lightning strike on the power system, which happens all the time. But only those two things, that's all it's there for. Here's what it kind of looks like. Here's your power pole transformer. There's a couple of phases. There's a neutral. There may or may not be a ground connection at the pole. Those go to your AC service panel. If you open it up and look at it, you'll see two big buses. One is for the neutral. This is all the white wires. This is where all the green and the Behr wires go. These are usually connected together at your service panel. That's connected to the metal of the enclosure, and that's connected to the outside grounding electrode, which is probably a ground rod or two. Everything inside this blue outline is your AC service common point. That's where your AC service safety grounding goes. If you're not real sure what you're doing with AC wiring, and I know we can all kind of do a branch circuit or install some switches and maybe some outlets, things like that. But once you get complicated, if you don't know what you're doing, get a how-to reference. And the one here on the slide is a very good one. It costs about 20 bucks or even less at the big box stores or online. It's very good. It shows you how to do everything safely. Lots of nice pictures. All these strange devices that are out there now for home wiring and appliances, and how do you ground them and how do you not ground them. That's all in the book. Finally, look for rules on subpanels and outbuildings. If you install a subpanel for your station, either in a garage or a basement or out in an actual shack, there are special rules for this to prevent electrocution hazards. I was unaware of these when I started working with the book, and I am very aware of them now. Find these rules and follow them to prevent electrocution hazards. And finally, you can hire a pro electrician to do the work if you're not comfortable with it, or if you're comfortable with it, have somebody that knows what they're doing inspect your work and say, nope, you don't want to do this, you want to do it this way, or maybe they'll say good job. At any rate, they've learned a lot of things about what's safe. Take advantage of that information and have them check your stuff out. Remember that local code is the law. You can probably do whatever you want in your house, but if you cause a hazard, if you burn it down, whatever, it's on you. And the local code is not there to make your life difficult. It's there to prolong it and also to prevent fire hazards and other things. So know what the local code is and try to follow it. Lightning protection. Lightning comes from thousands of feet up in the air. You can't steer it, but you can help it make good decisions. What does lightning want to do? It wants to get to the earth, and it wants to dissipate an imbalance of electrical charge. So give it a heavy direct path into the earth for that charge to get out there into the earth and get away from you. For lightning protection, the connections of the inductance of the connections are more important than the resistance, because lightning is a pulse event, so it has AC components up into the VHF range, and voltage in an inductance is the rate of change times the inductance. So you got a big wad of current changing very fast. So you don't want very much inductance. You want to use big, heavy, direct paths with low inductance. That's more important than the resistance. Make sure the path for the lightning is outside your residence. Don't make it easy for lightning to go through your station or your house on its way to the earth. Give it those heavy direct paths outside the building. Here's an example of typical house. You've got an AC service panel, you've got a telephone, you've got a TV, maybe you've got a broadcast antenna on the roof, and they're all connected to a ground rod like they're supposed to. Okay, that's just terrific. But what are the ground rods connected together with? Dirt. Okay, dirt is very resistive. It could be 10 or 25 or even higher ohms of resistance between these ground rods. So what happens if there's a big lightning pulse in the thousands of amps between 10 and 25 ohm connections? Well, you get 10 or 25,000 volts. So that can be very hazardous and destructive. So outside the house, you bond all your ground rods together with heavy wire, number 6, number 8, number 2, whatever you got, whatever your code says, and you use properly rated clamps if you're going to bury them. You can use the welded connections with one-shots or CAD welds, and those are kind of fun to use, and you create a great perimeter ground. Some people put the ground all the way around their house. Sometimes you can't do that because of driveways or whatever. Put it around as much of your house as you can, particularly outside your station, and bond all that stuff together. Here's an example. You've got a tower out here. Here's your tower, feed lines, nice little entry panel. You got the ground rod, just like the books show. But there's also this path to your radio through your feed lines and then back to the AC branch circuit to your service entry, and it's got a ground electrode out here, just like the code says. Well, lightning comes down here, maybe it hits directly or maybe it's just nearby. A lot of current flows down that tower and along your feed lines, and sure, some of it's going to go into the ground rod, but some of it's going to divide and say, hey, there's this nice path through the house and through the AC service entry to get to this ground rod. That's where the damage occurs. So you don't want to have paths through your house that are just as good as the outside paths. You want to make the outside paths way better than the inside paths. Lightning is electricity, and current divides through different resistances, whether it's in the milliamps or the mega amps. So what you want to do is create your outside perimeter ground, your tower, your ground rods, your service panels, all your different communication services, your AC power. All of these are connected through this big, heavy outside station lightning protection ground, a perimeter ground around your house. So when the lightning comes from a strike on the lines, for example, comes in here and it sees this great ground connection outside, almost all of it will go outside, and that's what you want. It'll dissipate that charge into the ground, and furthermore, everything goes up and down together. So whatever voltage exists out here, all of your internal connections will go up and down together, and you don't have hundreds or thousands of volts between different parts of your house. Out on the tower, we've seen this in the handbook for a long time. This part of it right here, you're looking down on the tower, you got your tower base. Each tower leg has its own ground rod, and you've got a big ground ring around the outside. Well, if you want to really help that lightning get to ground, what you need to do is add some radials. Add a nice big radio wire, 30 feet or more long, couple of ground rods in there, and help that charge dissipate. One for each one of these tower legs out here. And that can be connected to your station ground as well. And on the tower, you want to bond your feed lines to the tower every 50 feet or so. Yeah, it's kind of a pain in the neck, but if you get a hit on a tower and the current is flowing down that tower and it's got some inductance, you can have 100,000 volts between the top and the bottom of a 50-foot tower from a lightning strike. So you want to bond your feed lines to the tower using a bracket like this, or maybe one of the grounding kits. And yes, it's kind of a pain in the neck, but it's better than losing your feed lines or having arcs through the feed line. If you've got an insulated base tower, add a spark gap across it. It can be as simple as a pair of heavy wires crossing and separate it a little bit so that when the voltage builds up, it arcs over. The arc holds the voltage down until the current is dissipated. And here's your single point ground panel. You've done your tower and now the feed lines are at your house. A single point ground panel is nothing more than a piece of metal on a non-flammable backing, and that's attached to some kind of a structure. Your unprotected lines, that includes the branch circuit that runs your radio equipment, your antenna feed lines, your telephone or data service, and those are all connected to the various types of protectors. There's one for telephone and rotator cables. There's our good old lightning protectors that we can buy for our coaxial feed lines. Here's our protected line duplex outlet, and we'll see an example of one of those in a minute. They're all bolted to this grounded panel. Here's our ground connection that goes to the perimeter ground system, and there's also a ground connection back into our shack. We've got our protected lines over here. We've got our unprotected lines over here. Keep them apart from each other. Don't bundle them together even if they look nice. Don't give lightning a path around your protectors. Lightning's happy to jump between the unprotected and the protected stuff if you bundle it all together. So even if it looks a little clunky, make sure you keep your cables that are protected away from the ones that are unprotected. Here's some examples of what goes on your single point ground panel. This is an isobar trip light surge protector, and you can buy these with 2, 4, 6, 8 outlets, and they're rated in the amount of energy that they can dissipate, typically around 3,000 joules up to 5,000. Buy as much as you want. These are not expensive, and they're available online and from electrical supply houses. Here's the antenna protectors that we know. They're called lightning arresters or lightning protectors, whatever, and you attach your feed line on either side. They've got a gas discharge tube inside, and that shorts out the transient inside your cable. Here's the multi-line protector here. You can see MOVs, or little transient protectors, and you can see gas discharge tubes. Here's an example of a single point ground panel outside my station. I have 3 towers, and I have one of these at the base of each. And you can see I have a piece of aluminum flashing. It's mounted on a piece of plywood, which is not non-flammable, but that's mounted on this fiberglass electrical panel, which is not flammable. You can see my heavy ground wire here, and this is an RCS4L remote coax switch. It has a gas discharge tube on each feed line. I've got my rotator cable here, and I've got a gas discharge tube on each one of those. I buy them in bulk from Mauser Electronics. There are other sources. Here's K4RO station. His actual station is up here somewhere. This is in his basement garage, and what he did was he was losing equipment in lightning storms. He lives in Tennessee on a hilltop near Nashville, so he took a big piece of aluminum, he bolted it to the cinder blocks. Here you can see his ground wire that goes to the outside ground system, and he bolted everything having to do with antennas to this piece of metal. Filters, switches, controllers, everything. And since he's done this, he's not lost any equipment, and it's been some years. So he's gone from losing stuff on a regular basis to not losing stuff, and saved him a lot of money. Here's a single point ground panel in my station. As you can see, it's a rack. It's a big metal rack. All this equipment is connected to the rack. You can see a ground wire here. Here's a big metal panel. Each one of the stations, there's a station here, there's a station here, is connected to the single point ground panel with these big heavy number 6 wires. And then there's a big heavy number 6 wire that goes outside to the perimeter ground, which is right on the other side of this wall. You should definitely look at Ron Block's lightning protection articles. He talks about the idea of a protected zone where everything inside this zone, every wire to it that crosses the zone line has to be protected by a common or bonded ground connector. If you don't do that, then the one that you don't protect will be where lightning gets in. And bond all your equipment together in your station as well. RF management, everything in your station is an antenna. You're right in the near field of your antennas at HF, and so there's really no getting away from it. You're not going to be able to create some magical 0-point RF ground. So forget about that. Concentrate instead on bonding. Remember, you want everything to go up and down together. That means 0 volts between them. You don't know what the absolute voltage is. You just want them all to be at the same voltage. So you got to keep your connections electrically short so that they don't start acting like transmission lines. Keep everything at the same voltage. And if you add an amplifier with high RF field strength, that will require extra attention to bonding. And I assure you that the equipment in your station will let you know if it's not adequately bonded the minute you light off your amplifier. So you can really save yourself a lot of problems by creating a common reference plane and or bus. That keeps you from having to tie everything together with individual wires. Inside the shack, you create your bonding bus by using a big piece of copper pipe as the usual. Use ground clamps to connect your straps or wires to each piece of equipment, including the non-powered ones. If it's got exposed metal, you want to connect it to this RF bonding bus. And then there's a big strap to your single point ground panel over here. That eliminates hot spots like a hot mic or something. It reduces audio buzz and hum on your low-level audio connections, and that's very important because that's how we do digital modes now. So you don't want to be adding buzz and hum to your signal. It reduces RFI, as we talked about before, from the common mode current being caused by picking up RF. Flows along the connectors. Why does it flow? Because of voltage differences. So if you zero out the voltage differences, it minimizes the current flow, and that's what causes the RFI most of the time. It also reduces sensitivity to physical configuration, so you don't have to move things around, so it works on different bands. Okay, so you're going to use short or coiled up cables. Sometimes you can't buy an exactly right length cable. So you coil it up and you lay it on that RF reference plane or right on the bonding bus. You minimize the loop area. You can't get rid of the loops. Any kind of extra connections, if you have 2 connections between 2 pieces of equipment, just a couple of coaxial cables, you made a loop. There are hundreds of loops in a typical ham station. You're not going to get rid of them. So just minimize the area. The voltage induced in a loop is proportional to the area. So by shrinking down the area, you also shrink the voltage. And you do that by keeping your cables together or coiling them up. And you always use shielded cables and short straps or wires, even for power. Here's an example. This is one of my stations at the place with the rack that you just saw. This is just a piece of 1-foot aluminum flashing bolted to a Costco folding table. And I've got a piece of copper pipe in the back, and the radios and filters and stuff are tied to the copper pipe, which is tied to the reference plane here. All the cables lay on the reference plane, and that keeps all of those cables at the same voltage, keeps RF from being from inducing current in them. And then you can see the big copper wire that goes over to the single point grounding panel on the rack, and that helps prevent RF pickup and common mode current and all this kind of stuff that cause RF problems in the shack. Here's a schematic. Here's your typical station, perimeter ground, heavy wire outside. Every external earth connection is bonded together. Your tower is grounded. It's bonded to the perimeter ground system. If it's more than 50 feet from your station, this becomes less effective, but it doesn't hurt anything. The military grounds everything up to 200 feet away from the station, but we don't have their budget. So typically we recommend if it's up to 50 feet from the house, bond it. Otherwise, it's up to you. It's kind of optional. Here's your AC power panel right here, your single point ground panel here, your ham radio stuff's all bonded to this bonding bus, and that's bonded to the panel. So are your antenna cables, your phone system, your cable system, everything's kind of tied together. You help everything go up and down together. Okay, at this point, I'm going to stop, and we're going to have some Q&A. I'm going to turn it back over to the moderator.
Okay, I'm going to stop sharing for just a minute. A couple of elaborations on what Ward was saying. You heard a lot of references to strap, and if some of you haven't seen it before, you can get straps that look something like this. There's kind of silver, and they've got connectors on the end of them, and they're flexible if you're moving your stuff around a lot. So, and you don't want to use rigid wire. He talks about an RF bonding bus as being a copper pipe, but you can have other things in an RF bonding bus, like DX Engineering sells this big bracket here, copper. You can bolt this to table, wall, whatever you want, attach your different connections to your chassis here, and that'll serve as a bonding bus as long as you run one wire from here out to your external bonding area. Number 6 wire, kind of the standard for what he talks about is heavy wire. If some of you haven't seen it, I was going to bring this to the meeting, but we'll just kind of show it here. You can see it's a little more wire than you're used to working with AWG12 or AWG14, and you're probably not going to cut this with a pair of diagonal cutters. You're probably going to be using a hacksaw to cut this stuff. Let's see, grounding rods. I'm not going to be able to show the whole thing, but you can get these things at basically Lowe's, Home Depot, something like that. Typically 8-foot steel rod, copper coated, pointed on one end. And these rods get used mainly for your service panel ground, but they work fine for the grounds that he's talking about as well. Let's see. I think that's what I wanted to talk there. So let me go on to, I'm just going to talk about a little bit of experience that I had, some kind of a practical applications of what he was talking about. And then if we've got some time, we'll talk a little bit about questions. So let me go back to sharing the screen. So we will go through what I called my great grounding project. If everybody's still hearing me fine, somebody give me a thumbs up on the videos, please. Okay, thank you. All right, so let's see. Come on. Okay, so I undertook the project, probably about 8 months ago now, to do some improvement in the grounding situation at my own station. Here's the setup I had, and I think this is probably similar to what most of us have. You've got AC power coming in on a line. It might be elevated. Mine happen to be buried, but comes into your service panel here, where all your main breakers are and all that. And out of that panel always comes down a ground wire to an earth ground. The Brits use a term called earthing rather than grounding for something that is actually connected to the earth. And I think that's a good distinction that we probably ought to adopt on this side of the pond. Anyway, then of course the power went from there through the house wiring to my shack, which happens to be on the 2nd floor, and to the you know, the power supply and the computer and all that stuff. Just think of this as just your shack equipment, which was then connected via coax down to another arrestor down here. I was a good protector here. I had a polyphaser or AC, whatever, one of the lightning protection devices on the coax here that would divert current down into here if it was high voltage. And of course there the feed line went out into my antenna. And I thought I was in great shape until I started studying this stuff. And I said, well, what happens if for some reason your service panel ground protection here doesn't work? And you'll hear why in just a minute. Well, if you get some kind of surge on the line here and it comes into your panel and it can't be dissipated down into the ground, into the earth, excuse me, then that same surge can go down your electrical wiring through your house up here to your radio equipment, down the coax line until it finally finds earth here on the other side of the house. Current going through your house, not a good thing. Conversely, what if the service ground is okay, but the station ground over here, where you put that nice polyphasor conductor that cost you 30, 40 bucks in? What if that ground doesn't work for some reason and you take a surge on your line here from a nearby strike? Doesn't have to be a direct strike. Lightning strikes nearby can still induce voltages on your antennas. Well, then that surge comes down here. It can't get to the earth there, but it can go up the coax, through your radio, through your house wiring, down through, and finally find earth over here at the AC service panel ground. So not a good deal either. Still got power going through your house. So the solution, as Ward mentioned, is a perimeter ground. If you tie the service panel here over to the the station ground over here, then if either one of these is absent for some reason, there's still a path over and back and not through the house. And this is a path that you lay in here with your AWG6 or better wire and ground rods along the way to further dissipate the surges into the earth as it's going along this path. So I decided, okay, I want one of these perimeter grounds. So here's the setup I had at my house. Over here on the left-hand side, you see my service panel, and there's a wire that comes down out of the service panel here and goes into the ground, and there's a ground rod buried down in there. The guy that built the house put that in for me, right? Now there seems to be some kind of law that says for a ham radio shack inside a house, it will always be on the exact other end of the house from where your electrical power comes in. And that's the situation I'm in. All the way on the other end of the house here, up here in this upstairs window is where my shack is at. And the protection I put in was a ground rod mounted over here. Now remember, these two were not connected to each other yet. That was a distance of about 90 feet. So I said, okay, I'm going to connect those puppies. I started off, I said, I'll start from the service panel ground here because it exists, and I'll lay the wire around to the other side where my station ground is at. Now this is the top end of an 8-foot rod with a mounting bracket on top of it. These are my two antenna connections coming through their respective connectors. And if you get a surge on either one of these lines, it goes into this copper plate here down the rod. And there's also a connecting wire here that goes up and into the station for further grounding up there for RF bonding. So the deal was to connect those two together. So I came up with this highly structured, highly detailed plan. It said, okay, here's my house, here's the fence line, here's where the power comes in. There's a rod there already. Here's where the station stuff is grounded over here on the left-hand side. There's a rod there already. I need to put rods along this connecting wire here that's going to bond those together. And it's hard to find anything that is definite around here. And if I'm stating wrong information here, somebody tell me when I'm done talking. But the gouge I got was for an 8-foot rod. You wanted them to be no more than 2 times that distance apart. So every 16 foot, I put in another 8-foot ground rod. There's some folks that will say because of the sand in our area, you really ought to put them closer than that. There is a one that says if you put them together, you can't put them any closer than 6 feet because then they're really not doing any good. So I hope that's right. And if not, at least it's better than it used to be. So I gathered up all my materials here. Post hole digger. This is a post hole tamper, or fence post tamper, excuse me. Bunch of these 8-foot ground rods, some number 6 copper wire, shovels. Turned out that a very important thing in my yard was this pruning shears to cut through a bunch of roots as we went. There's a bunch of connectors here, which I'll show you in more detail in a little bit. And one tool that I ended up borrowing after I took this picture, and it turned out to be very good, was there's something called a trenching shovel that instead of digging a trench this wide, digs a trench built for irrigation pipes. It's only about 4 inches wide, and that is the one you want to use around here, not these. Okay, so of those, you might ask, which of these tools was the most useful for the whole project? And some of you who have been in the meetings before know that I decided that my most useful tool was a 17-year-old grandson who was willing to help me out. And he was a big help that day. He went up and down on his knees a lot easier than I did. So again, we started over here at the service panel entrance, and we dug out there because we knew we had to connect to that rod where we started. And lo and behold, what did we discover? The wire coming down here from the service panel, this thing that he's holding in his hand, was not even connected to that rod. I couldn't find a connector. I couldn't find that it had been welded to it. I don't know if it got broken, if it was never connected or what. But for the 20 years, 30 years that I'd been living in the house, my service panel was never ever connected to an earthing rod. So we fixed that. And then we started off doing the job we had really intended to do. Over here on the left-hand side, you see the path that went from the service panel, which is nearest us, down the yard, and around the corner here to the panel for the shack. And you can see, I hope you can see it. There's posts about every 16 feet there. So we would lay out 16 feet. We would dig a hole because we knew we needed some working room. We would dig the trench into that hole, and they would proceed to put the post down. If you've got one of these things, they are worth their weight in gold, and they're pretty darn heavy. But you lift that up, drop it down, lift it up. It's hollow, and it stays on top of the rod, and you pound it down, pound it down, pound it down. It saves you standing on top of a ladder trying to hit the top of the pole with a hammer. Much more safe. And my grandson actually thought that was fun to put those in, so that was great too. Eventually, you get down to the point where the bottom of this tool is hitting dirt, and then you're going to have to hammer the stake in the rest of the way with a sledgehammer. But that's a lot easier at that point to do than starting from an 8-foot tall rod. What we would do is take the rod, and we got it to the point where the fence post tool couldn't do anymore. We would then attach the clamp onto here. I will show you that clamp in more detail in just a minute. And then we would pound it the rest of the way down and run the wire through it and do the connection down there. Now let's talk about the connectors for just a minute. You can get this kind of bracket at any hardware store, and is designed for the situation where you have a single ground rod and you're running a wire from your service panel down to that ground rod, and you stick the wire in and you connect it and everything's great. But that assumes you didn't go on further to connect it to other ground rods down the way. This is one that I had to do a lot of searching and finally came up with. It's available from Crescent Electrical Supply. You can see it's segmented here, and this is where the wire is going to go through. So the idea is, if you're using this type of rod, this is a God's eye view. You're looking down on the end of the rod here. Here's the rod in a copper color, and this bracket goes over it, and you can see the wire is going to have to come down and go straight down vertically through it. This is a side view. It's going to have to come to that rod, go down, And ordinarily, if it was just grounding a service panel, it would stop there. But if you're going to keep going on, then you're going to come down and go up to the next rod and down and up to the next rod. And you end up with these sharp bends here, which is not a good idea. That's not something you want on your grounding rod. So the beauty of this one was this clamps onto the rod. Again, looking down from the top, you can see how it clamps on, but it's built to have a horizontal wire attached to it. Whoops, excuse me, sorry. So here's where your number 6 wire goes across here. And once this was on the grounding post and pounded into the ground, you just lay that wire through there, tighten up this screw, and you're in good shape. Which also means you don't have to go to the hassle of threading 9 connectors like this onto 95 feet of copper wire because there's no way to get it in there unless you do that. So this is my recommendation if you're going to go with just a straight mechanical clamp like I did. As Ward mentioned, there are CAD-weld, I believe, connectors that are available where you can put the 2 wires, the post and the wire together, and actually you light them off and they burn, and they hard weld these things together. And that's obviously a better connection than this. It was a little more difficult to use. It was a little more expensive, and I ended up using this way, but that's not the only way to do it. So, like we talked about, there's those 3 issues of grounding and bonding, and what I talked to you was just one of them here. Basically, was grounding. I still personally have a couple of tasks to do to get the station up to where I think it should be. One is I got to improve my RF bonding between the transceivers. I've got a couple of transceivers. I've got a computer. They're not bonded to each other like they should be. Another one is I got to work on my AC power distribution. What Ward didn't talk about in the video, but what he does talk about in the book is some of those cheap power strips that you've got for your computer or whatever, with a switch on one end and about 6 connections down the line. They are not built for repeated on-off cycles, and you can start to get yourself in trouble there. Also, there's usually not much protection there. One of the fellows that I brought by the house when I was doing some hands-on stuff for the general guys said, you know, right now your lightning suppressor is pretty close to the house. And so I want to move the first point where I've got lightning protection to the point where the coax first comes down and touches the earth and either runs across the ground or gets buried, to keep Mr. Lightning as far away from my house as I can and get it into that grid of distributed rods that I put in. And I'm going to consider the single point ground panel, although that's easy to draw on a piece of paper and hard as heck to do on a house that's already constructed, because usually you're using the outlet, and typically the outlet is on the wrong side of the room. So that's a little bit of work too. But anyway, it's like any other ham radio project. You're never really done. So that was the end of my presentation. Hope you guys got something out of it. If there's any questions, I can try to answer them. If not, we'll call it quits.
Hey, Mike, this is John Gentry.
Yeah, John.
Okay, Mike, I'm kind of new to Florida. We just moved here from Colorado. And I was wondering if there was any standards that you had seen for Okaloosa County as far as like solid copper vice any kind of stranded copper when it came to doing these ground lines. I've read that it kind of works either way, but I just also wanted to find out if that was the law of the land around here.
I'm not the expert on this. I'll admit that I don't know. The only code I was able to find said that if you were in a situation where you needed more than one ground rod, And there are situations like that. I mean, just for electrical purposes. Then you had to have those ground rods more than 6 feet apart. How far apart? I looked and I couldn't find it. Is there anybody there at the church that could help John with his question? Help me with my ignorance. Or anybody else on Zoom that could help for that matter. And remember, you guys are probably muted.
I've been told that it's twice the length of the ground rod. So
Okay,
if you have 10-foot ground rods, you're looking for 20 feet apart. If you have 8 foot, you're looking for 16 feet apart.
And I think I remember, Robert, seeing somewhere that says the code shall not specify a wire bigger than AWG6. So that's what I used.
I use 6 and a little bit of 8.
Anybody else? Okay, John, I don't think we really answered your question, but we showed that we're about as confused as you are.
Okay.
The only thing I've ever seen is solid, not stranded for grounds. I don't know what the exact rules are, but that's all I've ever seen.
Okay.
Yeah, and I figured if you were putting something into the ground that it wasn't going to be moving, solid was probably a better bet than stranded.
Yeah, the stranded would tend to corrode quicker if it's out in the elements, or if it's got any type of corrosive elements, dirt or water, or it would be okay indoors, but if you're going to do it outdoors, it needs to be probably in conduit, which runs up your price or your cost.
And definitely bare wire too, right?
Yeah, yeah. You want contact with the earth.
Good
Other
deal.
questions?
Thank you.
Thank you, John. Okay, let's not belabor the issue then. I will put in one more pitch for the grounding and bonding book. There's a whole lot of stuff in here that we didn't get to cover tonight, particularly in terms of how to set up your AC safety and how to set up that grounding plane that he was talking about, just a layer of conductive material on top of your desk or station or wherever you're at that would help help with the stray RF that's running around. If you think about it, for a 2-meter band, 6 feet, and if you study the feed line stuff about there's a null or a voltage null or a peak every quarter wavelength. So you've got plenty of antennas running around just in the sections you can touch with your hands. All right.
Hey, Mike.
Yes.
Mike, this is Bob Hurley, and I'm in the club here. I'll ask you a question, but maybe the guys here could answer it also. I know if I go through this again, I'll have a lot more questions. But one thing I noticed when he was talking in his presentation, he was saying keep all of your cables as short as possible inside the station.
Mm-hmm.
And that raises a question with me because I bought a new radio, got an IC 7300, and he said even the power cable. Well, the power cable that comes with the radio is long. I don't even know how long it is, but it's a long cable, and then it has fuses toward the end of the cable. So you're not supposed to, shorten that cable at all. So if I can't shorten it, then is it just coiling it? Is that the answer? Is that the thing to do?
I think that's probably your best option, Bob. Just coil it as, and clamp it together so that it looks like a big inductor that'll keep your RF from trying to move around.
All right. What's that? All right. We'll talk some more here in the club. Thank you, Mike.
Okay. All right. Thanks, everybody. I think we can declare this one complete. And Bruce, you want to tell us what's coming up next month?
And next month, we're going to have Rich Gerardin in for DPM, talk about our club station. They're on the property, on the church's property.
Okay, very good. I'm going to leave the net here and leave it open to the folks that are running our Zoom there at the church. Thanks, Bob. Thanks, Steve. Again, as usual, you guys doing a bang up job. We appreciate it.